Hello Internet. So I recently got a 3D printer and I've been poking around with some of the things you can do with it. And one of the things I started looking at is you use these files called STL files, which sort of define what you're printing. And looking at them, they're actually fairly straightforward. So this is going to be our 3D model. These are actually the same file. So this is a D20, there's no numbers on it, but you kind of get the idea, D20. And then this is actually what the file itself looks like. So this is literally just this file loaded. And if you look at this actually is really easy to understand. All you have is you're defining a solid object with a name. In this case, we have the D20 main. That's the name of the file. And then you just have these facets. So it looks a little bit like BASIC actually. So you have a facet that you begin and end, and then you have three floats, which define the angle of the normal, or the point that face is pointing at. And then you have three vertices. So you just build triangles and give it a normal, and that's it. That's all you have to do. And it just repeats. So each one of these is going to be a face in our model. So there's two things we can do with this. One, we can actually use this to load these models into Unity, because I don't think Unity supports them. But also, we can use this to actually generate these files for other things. So this is just for a D20. But what if we wrote a program where we could actually plug stuff in? And that's sort of what I'm thinking we're going to do. So in this video, we are going to actually build a cube in this format. So this is the ASCII encoding for a STL file. There's also a binary version, which is going to be more compressed than this. This is very verbose, and you can actually get it so you just need to encode these floats, and they're not encoded in ASCII, so you can actually do it pretty quickly. We don't need to worry about any of that. All we need to do is actually be able to generate something that looks like this. And we can do that really quickly. So hopefully we can generate this and then get it exported here and hopefully 3D print it by the end of this video. So I've already created a, whoops, that's wrong. I've already created a .NET Core project. There's nothing here, obviously. Because I'm not thinking this is going to be that difficult. All we need is just a really simple file writer. And I'm going to actually write a class to wrap this. So we're going to create an STL Mesh. Sure, we'll do that. So this STL Mesh class is going to be just a public mesh. And it's going to have a list of facets, I guess we can call it. Let's just go based entirely off of what they already have. And since we're already putting STL in front of everything, I'm not sure if I like that. Let's actually, just so nothing gets that crazy, I'm gonna just call this a mesh. Hello. And we're going to have this thing called a mesh, and we're going to have these things called facets. And facets are going to have vertices. So just for simplicity's sake, I'm going to throw each thing in a separate file. So we need a facet. And we need a vertex. And just to keep things simple, I'm going to keep everything as classes. There's no real reason to do that, but we're going to create a vertex. And it's going to have 3 points, so float 3, that's not how you do that, is it? No, it's not. Vertices. And we're just going to say this is a new float 3. So, we've defined this new vertex, and I want to be able to public, we don't want that public. The Unity is wearing off on me. We're going to create a public float with a getter and a setter. So x get return vertices 0. So we could have as I'm writing this, we could have, ooh, what am I doing? Done this a little bit better. Well, by better, I mean it would have been a little bit cleaner. We could have just had these X, Y, and Z each be their own thing. We don't necessarily need all of these to be inside of this array, but by doing that, we actually keep the memory close-ish, which for later optimizations, it kind of should help, I think. What am I doing? Sorry, it's hard to type and talk about something completely different. I'm trying to get better at it, but it's gonna take me some time. So I don't need to type this again. You doing all right there, Visual Studio? You do not look all right. All right, there we go. 3 of those. I'm gonna make this X, Y, and Z. And then we plug these in like so. So now we can create a vertex, and it's going to have an X, Y, and Z component. And let's just give it a basic constructor, just so we can actually start using this thing. So float X, float Y, float Z. And I'm actually going to give this default parameters. And this will give us a few things that we can do that I'll cover later. So what this does is if we don't specify any of these, it defaults it to this value. So if I just say, I can just say public or new vertex, and I'll get the 0 vector. But if I want something else, I can do new vertex and say like y equals 1, and I'll get something that's directly up, which I think should be a pretty useful shorthand. We'll see if that actually works or not. But then I can just set things like this, which is, that's a little bit confusing. These are the properties that we're referencing here. Just for clearness, I'm going to actually make this explicit. We'll see if that, kind of, it's a little bit better. And so let's pull back our little documentation. Our facets have a normal, and then they have 3 vertices. I think, I haven't been able to find an example, but I believe we can probably insert more than 3 vertices into one of these. Again, I haven't found an example of that happening. So for now, I don't know what to do. Let's create a vertex, a normal, I guess. The Unity is coming out again. There we go. And we'll just say this has a public getter. So a public get and a public set. That's not what I want then. This is not gonna like me. Let's just do this. There we go. Everything's getting a little bit out of hand, but that's all right. We've got our normals, and then I just need those 3 points. So we can either store them in a list and kind of manage that list, or I can have each point separately. Let's do a list of vertices. We'll just call it the vertices. And I don't think I want to do this. I don't want you to be able to set this list. I think that's a really bad idea, because if I let you do that, somebody's gonna, it's gonna get screwed up. I'm gonna screw it up. So this way, nothing outside of it can modify it. Property type vertex is less accessible than property. Oh, this is not a public class. So the default in C# is internal, I believe. Which means it's only exposed internally to things inside of this library. And so if we make something public and it tries to expose something that's internal, that's bad. You can't do that, because you're saying here's this thing that you can't have. It's like giving classified information to somebody who can't see it. Except you can do that, but that's a bad example. let's see here. Normal, vertices. How do we want to do this? Should we just... I don't know if this is a good idea. Probably not, but we're going to do it anyway. So we're going to pretend like you just initialize this normally. So you give it a vertex normal, and then some set of vertices. Vertex array vertices. Sure. So if you're not familiar with C# too much, these params are sort of like the dot in Java or anything else. It allows you to effectively provide any number of arguments. So we can just provide a normal vertex and then any number of additional vertices, and it will create a vertex, or it will effectively store all of those additional ones into this array. And that will be kind of a optimization that it does. Not really an optimization because I think it's slower, but anyway, totally getting sidetracked. We're going to create a new list here of vertexes, like so. And I think I don't want people to be able to edit that. I don't want to be able to edit that. And the reason we're doing that is so this will be somewhat immutable. It won't be immutable because our vertices are not actually immutable classes, but we can fix that. This sort of one of the things I like to do is keep things that shouldn't be messed with away from people that want to mess with them. So what I've found is if you allow somebody to do something, they're going to do it. And so if you make too many things public, people start doing weird things. Or if you allow people to like insert into your list, like if I return this, it would be possible for somebody to say, grab that list and then start inserting things somewhere else. And maybe I don't want that to happen for some reason. Maybe there's some calculation that I want to do to remove unneeded vertices, or split this facet into 2 if we add an additional vertice, or something like that. That becomes a lot harder if people start pulling out this list and doing their own modifications. So by making it something that you can only iterate over, it makes everything a little bit easier. At least for me. It makes it harder for everybody who's actually working with it. But that's fine because I don't really want them messing with it in the first place. So vertex in. So what I'm doing here is I'm going to be iterating over our vertices, and I have spelled that wrong. That feels more wrong, but whatever. So for each vertex in that vertices list, we are going to add it to this dot vertices. I think I could just do that. So never mind that. We're not going to do that. We don't need to. The list initializer, the list constructor, already takes an enumerable object, and will just automatically construct that for us. So we don't need to do that. Getting way too far ahead of ourselves. So what we do need here is we have this list of facets, which is going to have a facets get and a private set again. So again, you can't set this list. Enumerable. There we go. So you can't set this again, but you can get it if you need it. Feeling like I missed something. Nope, I'm going to pretend like I didn't. Okay. So the next thing, we're going to do a string, and this is going to be called the name. So one of the things you may have seen in here, there is a name that's used at the end and all the way at the top. So this is optional. You don't need this, but if you don't have it, you still need that space there. So we're going to add it just because that way you can actually keep your name of things and import named things, which seems like a useful trait. So we have this facets public mesh. We're going to create something with a name. And I'm actually not going to give this any facets at all. And I'm thinking we may be able to do something fun with this. I'm thinking builder pattern, which if you're not familiar with, it's more of a functional way of doing that. So let's do that. This is gonna kind of sidetrack us a little bit, but that's fine. So this dot name equals name. That's just gonna set the name. I'm going to build a mesh builder. So mesh builder. So usually these are totally separate classes, and they're just sort of designed as functional constructors. So the idea is you can kind of specify things in any order and however you want, and you can kind of do that over an extended period if you need to, without like having to collect all of your information and then pass it all into a constructor. You can kind of say, I want to build this object with these parameters. So the way it normally looks, I can't think of a good example in C# off the top of my head, but let's see here. Public mesh builder. I'm going to just do a really quick example. So think of it similar. Ooh, that's not going to work, is it? Think of it similar to how you'd use like link. So you do like list dot. We want to get, say, what is it? Let's find everything that has something. So you'd give it some parameter. I'm just going to say true. So effectively we'd find everything. And then you continue on and you say, and we want to find everything that has where something. And you keep going. That's sort of how this is designed to work. It's a contrast to like the factory pattern, where you have some static builder method that will automatically build things for you. You don't get that here. Instead, you get some sort of builder, and it can kind of, the idea here is it can kind of handle things that aren't specified. So if you don't give it any, like if we didn't give it any mesh name or something, it could come up with some default. Or if it didn't come up with, if there were no facets, it might throw an error or something and say you can't build a model that has none of that. And so you can kind of handle those in a better way, because normally you don't want to throw exceptions in your constructors, which is what you'd have to do in some of those other cases. Or you'd have to like wait afterwards and do weird adds or something. So this way, theoretically, we can get a little bit better pattern going. I don't know if this is actually going to make it better. Normally I wouldn't do this right off the bat, but I kind of mentioned it, so I feel like mesh builder dot, what do we want to call this? Create. I don't like that name, but fine. So we're going to create some new mesh is what this is saying. And so what I want to do is I want to return a new mesh builder. And so we're just going to kick that back out. And there's nothing going on there. Normally I do it this way. So there's sort of like a factory to create the builder. And then you have just a private constructor here to kind of get things started. So we're going to have two things that we need for this mesh. The first thing is going to be string name. So we're going to have a name and a private list of facets. Do I want to store facets? Sure. Facet, and we'll call it facets. Cool. So I'm creating these two things. We'll set the name equal to some unknown object. And we will, I'm going to put a dash in there just because spaces tend to lead to problems that I don't want to deal with. So we're going to catch those before they get to us. All right. And then we just create an empty list of facets. So basic builder, I guess. Then like the big thing that the builder pattern usually does is you'll notice it returns itself. And that way you can kind of chain functions one after the other. And you don't really need to worry about execution, and it kind of lets you do it more in a fluent style. So you can say, very similar to link, you can say, select all of these things where this is this, and sort them by this. You can do that, and you can kind of chain it all in one instead of saying, create this object and convert everything into this, and then store it in this. And then with that stored object, filter it by this, and then store it in this, and then with that other filtered object, put that in here and sort it by this and store it in some sorted array somewhere. That's really hard to follow. And the more complex things get, the harder and harder it gets. So this kind of makes it easier to kind of chain those things and maintain those things and stuff like that. So I'm getting totally sidetracked by this, sorry. Let's see here. Mesh Builder, we want to name it. So I'm just going to give it a name like so. We want to do this dot, I can't do that. Name. And we're going to set the name equal to the name in our function, and then just return this. So this seems silly. Like, why would you do that? And the reason is so you can get that chaining going. Otherwise, this seems like a waste. But it is nice. Trust me, it's nice. So then we're going to have another mesh builder, and we're going to say add or with facet. And we're just going to plug in a facet here of name. Oh, that's not it. Facet. Sure. And so I can just do facets, add, not a new one, there we go. And that will just add it, and then I need to return it. Return this. Thank you. Cool. So we're effectively, this is basic stuff, and then I can add some other simple functions. So we'll do another with facet overload that has a vertex. And that's going to do, what do I want? Let's just do the facet constructor. We can actually plug that in. So params vertex array of vertices. And I want to do a new, or facets.add of a new facet with the normal and the vertices. So the cool thing is, since this is an array parameter, if I should just be able to give it this array, or I can give it the list of vertices if I want. Either one will work. I'm missing a parenthesis there, but you can do either one, which makes it actually fairly versatile. I don't think you can do that in Java, if you're familiar with the Java version of this. So there are some differences there, but other than that, we want to return this. Cool. So I've got 3 functions here that can kind of build this thing, and then I want to public build a mesh, and we're going to say build, I guess. I'm not going to handle a lot of the edge cases right now. In the future, we can probably do some of that stuff, but I just want to return a new mesh with the name that and the facets equal to that. Will that work? I don't think I have the constructor for that yet, but I'm wondering, do I want to generate the mesh like this? Or do I want to have some addition afterwards? I think this makes more sense. So we're going to have an enumerable facet of facets. Cool. I'm breaking everything, but that's fine. There we go. So we're going to set the new facets equal to a new list. And so I'm copying this specifically because there's some bad stuff that could happen. Just because I could say, create this list, pass it in, and then be like, oh, I want to continue using this list and start adding things to it again. And that would have the side effect of actually modifying this mesh, which I don't want to happen. So to avoid that, I'm going to duplicate it. So we're going to actually take what the inputs we're providing and actually copy that into a separate list that's going to be internal to this mesh. And that kind of avoids the side effect of modifying two things. All right, so I have something that can actually build this now. Took a little bit longer than I wanted, but that's all right. And now I have this hello world program. So I want to build a cube. We're just going to use a cube for now because cubes are easy. And I actually know the formula for that. In the future, the reason I started looking into this is because I wanted to build something that could actually snap into itself. I screwed that up way too many times, but I wanted it to be able to be procedurally increased, and I couldn't find a good way to do that. Maybe Blender or something has something, but I wasn't finding anything, so I was like, I'll just write a program to generate that. But I needed something that could create these files, so that's sort of why we're doing this. We'll get to that when we get there, but I want to build a mesh. Yes. That was a long tangent to do a print line. How big should it be? So we're just doing a really basic box. So let's just get some input on console. Ooh, that's wrong. Console, we're going to read the line, and we are going to read that into here. Line width, I guess. So we're going to make a perfect box, so there's not going to be any other size. And you'll also notice there's no unit of measure here. One of the things that I hid when I was working with this, you actually have to select what unit size you're working with. So I selected millimeters, that's why everything is in millimeters. 3D Builder is going to give you some other options like inches and stuff. And if you want to learn more about 3D Builder, I have a video on 3D Builder and Paint 3D that kind of goes in depth into how to use these and also how to get them into like another 3D program like Unity or something like that. So check that out. I'll put a link in the description and you guys can check that out if you haven't already seen it. So line width, we're going to read that in var. I'm going to just call this the width. And this is just going to be the parsed version. So int32.parse of line width. For now, I'm not going to validate this. This is just a proof of concept anyway, so I don't really care that much. If it breaks, I can always redo another one. So once we do this, I just need that line builder or that mesh builder. So we're going to do just a builder of the mesh builder dot create. I am doing way too much Java stuff because that is not what I want. All of my names are lowercase, aren't they? Oops. One sec, let me make that not bad. Sorry. There we go. Vertices and normal. I knew I was missing something in here. So this is just to align with C# standard practices, because otherwise I'll forget everything and it will be bad. There we go. So we've created a mesh builder. I'm not going to get too in-depth into the builder pattern again. That wasn't really intended for this video. It just sort of happened. So what I do need though is I do need to name it, so we can do a builder dot. Actually, sure, why not? We can. Just to show you how useful this can be, or how confusing if you do it wrong. Because this might be an example of what not to do. We are going to create a box. And then I am going to add a facet. And then I'm going to do, we need 2 of these per side. So that should be 12 total. So we're gonna have 6 lines here, and we're gonna need a normal. So let's do up first. So new vertex of up. Do I want to do it this way? Not really, but whatever. So we're gonna do 0. Actually, I was talking about this earlier. So remember how I said how you can do default parameters? We can do something like this, I think. No? Y does not exist. There we go. No? What? You're right there. Public float Y. I feel like I have been lied to. Y does not exist. Oh, okay, that... Well, that got annoying. I thought you could use named parameters like that. Maybe I'm not doing this right, but I could have sworn you could set, if you had optional parameters, you could actually do them named. So you could name them in the constructor and then it would apply them. I must be doing that wrong, so my bad. That's less cool than I was thinking. Sorry. So we need facets. So these are going to be triangles facing wherever the normal is facing. So this normal is facing up, straight up. So we are going to do the top first. That kind of makes the most sense. And then I just need new vertices. So we are going to do up, and it's going to have a width. Well, actually, let's do half width equals width divided by 2. Cool. So since this is going up, and I'm going to try to actually send... do I need to center this on the ground? I don't. So we can actually just do half width, and half width. And that should be top corner somewhere. I don't know what kind of unit space it's using, so I can't say like top left or something, but it's going to be up, positive. And that's all I know. So I need that again. So half width, and negative half width. Cool. So this is going to be a line going along the X border from negative to positive, or from positive to negative Z values. And then another one, new vertex of half width, and half width. Cool. So this can be either positive or negative, but I just need to complete this triangle. And then I need to figure out 2 shared sides to actually complete the next bit. And I'll do one side and then I will jump cut, because this is just going to be a bunch of typing. Well, actually, it's going to be a bunch of copy and paste. That didn't work as well as I had hoped. So we need this up again, and then I need to actually zoom in so you guys can read this. Sorry. Oops. I don't know if I can fix that later. But anyway, so we have this triangle, and it's going to be somewhere up here, and it's going to look like that. I just demonstrated what a triangle looks like. That probably wasn't very helpful. I'm gonna carry on. So we need to cover the other vertex, which is going to be negative and positive on the XY plane. And so now that we have that was all I needed to do, is just add this one negative. And then we have 2 shared sides. And so those two shared sides should connect here. I may have thought of that wrong. Let me think here. When you're building these triangles, you have this square, right? And so between my two hands, there's a line that goes. And so I need to construct this by sharing the two vertices that are shared at these 2 points between my two hands. Those 2 points have to be shared between them. If I share the other ones, it's not gonna work. So that's something to keep in mind. And I think I may have done that hastily, which may not have worked. So I think I need to share the two opposites, which will be positive and negative. And then this one can be flipped. So this is going to be in the positive corner because everything is positive here. And this one is going to be in the negative corner, which is because both of the X and Z coordinates are negative, which means they're diagonal from one another. And since they're both shared by both of them, this middle vertex is the one that I need to flip. That's how I'm getting to that conclusion. Anyway, eventually what I need to do is call build here, which is going to build this mesh and actually save it here. So this whole thing is all one giant chained function call that ends up setting this mesh to be whatever. So I'm going to go through and actually set this up and get the other 5 sides going. It shouldn't be too much work, but once that's done, then we need to write the serialization code, and then we should be good. And that shouldn't take too much time. Then we should be able to see if it works and print it. So I will be right back with this hopefully working. So BRB. So this is a disaster, but it works, I think. I actually have no idea if it works or not. We can actually find out. There's no reason I can't run this, right? Yeah, I can just run this and we'll see if this works. Or at least builds. I could have just built it. Why did I need to run it? It's not going to be helpful. Whatever. We're running it. How big should it be? 5. Cool. Didn't throw an exception. I guess that's all I need to know. That means the code's working, right? There's absolutely nothing that can go wrong if it compiles and it exits without fail. All the best programs do that. Clearly my program is pretty good. All right, I have a mesh. What I want to do now is actually encode it into this format. And I have everything I need for that. I have the normal, and I have these vertices, and I have the name. So now I just need to write something that can parse this into a file. So I am going to create a mesh string builder. STL builder. Sure. So this is effectively just going to take that mesh and return a string. Public, we're going to make this a static class because why not? What could possibly go wrong with that? And it's going to return a string from a mesh. So given a mesh, that's not how you spell mesh. There's no B in mesh, just so we're all clear. So what we need is a string builder. Got one of those. Builder, new string builder. So the reason we're going to use a string builder is because concatenating strings is a really bad idea. So strings, like if I just did string parse or like serialized or something equals something, and then just did serialized plus equals new something and just kept adding them, that would work. There's nothing broken with that. The problem is that strings are immutable types. So every time you do this addition, you're taking your two strings and you're allocating a new space in memory for that string, and you're actually doing the addition into that new string. So you're actually building an entirely new string. So suddenly you have this and this that both need to be garbage collected, theoretically, assuming you're just doing a bunch of addition. All of this stuff needs to go away, and that temporary thing, whatever serialized was before that, that needs to go away as well. And you just keep stacking that memory up, which for modern garbage collectors don't mind that much. They're generational garbage collectors usually, so they can kind of handle it, but not really. So usually this is just bad. If you're concatenating strings, either use some sort of string interpolation or a string builder. And builders tend to be fairly straightforward. All you have to do is just append. So what we need here, if I can remember how to do this, is we need a mesh.name here. So this is one of the new C#6 features, string interpolation based off of name. I've covered this a little bit before, but it's pretty powerful. You can actually take actual names from your stack and actually interpolate them in the string. So I'm going to need this actually. So we need solid and then just the name. And that is the entire first line. So I'm going to just do append line because there's new lines all over this file, and it'll just be easier this way. And just to make things even easier, let's make this a little bit like that. How's that? Sorry, this is getting gross, but I could have done that better, but whatever. It works. We can actually see what we need now. So at the very end, there's something we have to close this. Remember, it's kind of a basic syntax. So that's not how you do that. End solid, I think is what it's called. And it should just be the mesh name again. And so that's just going to close it. We can double check that, but I'm pretty sure I'm correct. Yeah, end solid right there. And that will just close it. So now that we have that, we need to do a loop and create these facets. So for each facet in our meshes facets, so for each facet, I need to go through and actually grab these normals. What am I doing? That's not what I want. We need to build append line of facet. Ooh, that's not right. We're gonna do facet normal. And then there's gonna be three values, which is gonna be the facet dot normal dot x, the facet normal y, and the facet normal z. And that should cover that line. So that covers this. That's what that string is going to do. Then, now that we have that, I should be able to do this next part fairly easily. But I'm going to close this first. It's just end facet. And that should be good. So we've got this bit done and this bit done. So there's these 5 lines in between. So that shouldn't be too hard either, because there's 2 of those that are fairly easy. We're going to do an outer loop. So I'm going to do a tab outer loop. And so this is exactly that. Just following their syntax. And this should be correct. I did do a little bit of reading on Wikipedia and stuff before this, just to make sure that I actually had all of this somewhat correct. I haven't actually implemented this ever, but we're gonna see if this works. It looks like there's spaces. I don't think that's relevant at all. I don't think you need those, because I think it's white space independent. I'm adding them just so that it's easier to read. I was going to use tabs, but if they're using spaces, I'll use spaces. Then we just need to iterate over the vertices. So for each var vertex in our mesh, or in our facet, sorry, vertices, I want to do a builder and append a line that's just going to be our vertex, and then we just need vertex.x and vertex.y and vertex.z. And so this should be the entire format. This is all we need to generate this entire thing. I just need to return the builder toString. And that will just output this as a string that we can use anywhere. And that should be it. I don't think there's anything else we need. So with that, I should be able to just do file.write. Yeah, file.write all text. So this is why? Okay, so we need a path and the contents. I don't know why IntelliSense wasn't coming up for that. That's fine. We're gonna do just generated.stl. And that's just gonna be our generated file that we just created. It should create it in this directory. So we'll create that, and then I just need the STL builder to build this mesh. And that should write it out to the file. We should be able to check that and verify everything is good. And I should be able to build it at whatever size I want. So let's do, how big should it be? A centimeter would be 10 millimeters. So that's just tiny. Let's do 5 centimeters. Is that too big? That might be too big. 3. So 30 millimeters would be, yeah, that should be good. We get this generated STL file. We get a random box. Everything looks good. It's all -15s. So the question then, that might open it in something completely different. But how do I open you? There we go. So it's open on my other monitor, which is fine, but I should be able to drag it in and drop it. And we get a cube. So this is what we just made in code, really. I don't know what else to say. So there's a few things. These STL files need to be repaired in 3D Builder. So you just click that and it does it. It takes longer for a bit more complex things, but this is just a cube, so there's nothing crazy going on. And we clearly got everything correct because it works. So I'm going to go 3D print this and actually see what happens. So this should work. This is obviously simple. We should be able to generate more complicated things. So anything we can define, any mesh we can create, as long as we can generate a function that will create a mesh, we should be able to create something that we can actually 3D print, I think. I don't actually know how well this is going to work. For cubes, I don't see a problem happening. For other more complicated things, like I have this example here. So this is a gyroid. It's kind of hard to see. So it's kind of a sinusoidal thing. Focus camera. I always complain about it zooming in and focusing on random things, but you can't really see this. but it's more or less just a bunch of sine waves all stacked together in a 3-dimensional format, which actually looks super cool. It's actually super strong. So this is about a little bit over an inch, and I can stand on this and it is fine. So that's pretty cool. But this is just mathematical functions that define this. And so there's no reason we can't write something that will allow us to actually build this at any density or whatever we want, or any other function for that matter. So that's why I think this is cool. There's a lot of things we can do with this, and if you have any ideas, I'd love to hear them in the comments, because I think we can have a lot of fun with this. The code for this will be out on GitHub. So I have a GitHub, and all of the code for most of these projects ends up out there. This might be a little bit different. I do have one of the projects I want to build with this that I might somewhat do on the channel. Might not end up on there. I haven't really figured out how I want to license it yet. But it's not really relevant to this. This should be fine, but there's a specific derivative of this that would be different. Regardless, if you want to play with this, go for it. If you want to build something else out of it, highly encourage that, because I think it would be cool. But otherwise, this is it. I'll probably stick some of the 3D printed clips after that gets done into here. But yeah, that's it. So if there's anything else you guys want to see, or any feedback you have for me, I'd love to hear it. If there's more videos you want to see from me, hit that subscribe button, and that's hopefully you'll see more. I don't know, I try to put out videos 5 times a week. This week less because of the holiday, but hopefully we'll be getting back on schedule. Yeah, so I don't really have anything else to say, so I'm gonna leave it here. Hope you guys enjoyed it, and I hope you'll stay around for more. So till then, see you, internet.